Hello students, this is lesson U2A04. By the end of the lesson, you should be able to say I can identify different rigid motions used to transform two-dimensional shapes. So quickly, let's recap what exactly was a rigid motion again. A rigid motion is any kind of motion, any kind of movement that preserves length and angle measures. So what kinds of rigid motions exist that we've covered thus far? Well, we've talked about concepts of translating something, and to translate something means we can move something in the horizontal direction as well as in the vertical direction. We also talked about reflection. So if I take a point and reflect that over a line, okay, or actually if I take an object and reflect it over a line, okay, all the lengths, okay, of that triangle still is preserved. All the angles are still preserved. And then in the previous lesson, we've talked about something called, not previous lesson, but the two lessons before that, we talked about something called a glide reflection. And what exactly is a glide reflection? It's a composition of translation or reflection, or vice versa. Okay, a reflection or a translation. And then the last rigid motion that we talked about was a rotation. And in particular, we talked about rotations of multiples of 90 degrees on a coordinate grid. So all four of these are examples of rigid motions. So the composition of two or more of these rigid motions, yes, it still is considered a rigid motion. So any four of these, when in a composition together, okay, are considered rigid motions. All right. Any object subject to a rigid motion, its image will be congruent to the original image. Let's just think about this statement here. Any object subject to a rigid motion, the image will be congruent to the original object. That makes sense. If I take a triangle and I translate it and then reflect it over some axes, I'm going to end up with a triangle that looks like this. This is the two triangles there are going to be congruent. That's absolutely true. Again, this is all true because all rigid motions preserve angles and distance. All the side lengths of the triangle just described right now, all the side lengths are the same. All the angle measures are the same. Okay, so this chart right here just sums up all the different elements that make up rigid motions. I encourage you to pause the video and take a good look at this, but this is also one of those study sheets, okay, that I've put together for you, to, reference guides, okay, that I've put together for you that you should have to analyze and to look over. All right, so we're going to take a look at our first example for this lesson. So is the transformation from ABC to A prime, B prime, C prime an example of a rigid motion? And how do you know? So we're going from ABC to A prime, B prime, C prime. There's not a single way of doing this, but you know, any way that you can get from ABC to A prime, B prime, C prime, I encourage you to pause the video and think about this. All right, so now that you had some time to think about this, is this transformation from ABC to A prime, B prime, C prime a rigid motion? And how do you know? Well, absolutely. This is 100% a rigid motion, because if you look at this, okay, AC here and A prime, B prime, and A prime, C prime, they're the same length. BC, B prime, C prime, A prime, AB, and A prime, B prime, they are all the same length. These two triangles are indeed the same, okay? They all have the same exact angle measures and everything, okay? So yes, this is in fact a rigid motion. Okay, so now we need to explain if the rigid motion is a translation, a reflection, or a rotation. So upon inspection right now, okay, taking a look at this, is this a translation? If it was indeed a translation, we should be able to move this and then translate it there, right? But it doesn't look like it will land exactly in that orientation. So with that said, what do you think it is? Of course not. It's not a translation because the orientation of triangle ABC is not the same. It's not preserved. The orientation is not preserved. Well, is it a reflection then? Well, in order for it to be a reflection, we're reflecting it over, let's say, this axis here, okay? We should be able to land right here then. However, that's not where A prime, B prime, C prime is. So this is not quite a reflection either, because the line of reflection, because there's no line of reflection between this, okay? Even if we rotate it, if we reflected it over there, okay, in that manner, it still wouldn't exist. Okay, so what is this then? So in order for us to go from ABC to A prime, B prime, C prime, what would happen is and finally, is this a rotation? My mistake. This is a rotation. This is not a rotation because if we take this and rotated it, okay, the triangle would then end up being upside down. And that is not a rotation. Again, because the orientation is not preserved. So the combination of which rigid motions will map ABC to A prime, B prime, C prime then? Right in a proper notation. So again, there's no one correct answer for this, okay? If you were to write a rule, okay, to describe this rigid motion, what would that be? Pause the video. Again, there's no one right answer for this, so let's see. So having thought about this, let's take a look. All right, so we can certainly perform a reflection first. So capital R over x equals to -1. And if we do that, we'll end up there. And then we'll need to perform a translation. So either way, okay, we're translating this down 5 units. So the notation will look like this. We're reflecting over x equals to -1, and we're translating 5 units down. Could this have been done in reverse order? Absolutely, and it wouldn't have made a difference. All right. What is the glide reflection that maps JKL to J double prime, K double prime, L double prime? Use proper notation. Write a rule that describes the transformation. So I'm going to encourage you to pause the video and see what you can figure out here for yourselves. So welcome back. Hopefully you had some time to think about this. What you want to do, okay, or at least what I had thought of, was perform a reflection and then a translation. So I reflected over the line y equal to 1. Hopefully you did something similar. And again, there's not a single right way of doing this, okay? After you reflect, then we translate. You could have also translated and then reflected. Either way is the same thing, but the notation, okay, will look like this. All right, let's take a look at another one. Write a rule that describes a rigid motion. Name all sides and angles that are congruent between triangles ABC and DEF. So I have, what we need to do is we need to first plot out triangle ABC, and then we're going to plot out DEF. And it looks like this. We want to go from ABC to DEF. Now, how will that look? Looking at the orientation there, is it going to be a translation? Will the orientation be preserved? Will the rotation be preserved? Will the orientation be preserved if we perform a rotation? Pause the video and see if you can figure out what the rule is for going from ABC to DEF. So we can perform a reflection first over the x-axis. You don't have to perform a reflection over the x-axis, but I chose to. And then we translate this this object 1 unit up and 5 units over. So we end up with a composite transformation in this form.